Now let us do a couple of questions on parametric differentiation. First example says that there is a curve which has the parametric equation as x is equal to t square, y is equal to 2t. In the first part, we have to find out dy by dx in terms of the parameter t. Means we do not need to eliminate parameter t, right? So as I told you earlier that dy by dx is given by in terms of if there is some parametric equation is equal to dy by dt and upon dx over dt, right? So I have been given y is equal to 2t and x is equal to t square. So I can differentiate y with respect to t as dy by dt is equal to just 2 and dx over dt is given by 2t. Okay. So my value of dy by dx is equal to dy by dt is 2 over 2t. Okay, so it is just 1 over t. Since it is given in the question that in terms of parameter t we have to find out dy by dx, so it is just 1 upon t. Otherwise, we can replace the value of t with either under root of x or y by 2. Okay, so this is your first part. Second part says we have to find out the equation of the tangent to the curve at the general point t square and 2t, right? So this is why it is saying that this is the general point, because t square, as we say in Cartesian system, that our general coordinates are x and y. So this is basically t square, which is just your x, and 2t is your y. So basically these are written just x and y. Okay, but here the two coordinates x and y, they are just replaced by a parameter t, right? So equation of a tangent is given by second part I am doing here only is y minus y1. y1 means the coordinate of y is 2t here is equal to m, which is 1 upon t or dy by dx. X minus x1 is t square. Okay, you can reduce this to more simpler forms. This is y minus 2t is equal to x over t minus t. Okay, so this is your equation of tangent in terms of again point P. Third part says find the equation of this tangent when value of t is given as 3. So just put the value of t in the equation, which is 3. Third part at t is equal to 3, equation of tangent is given by y minus 2 into 3 is 6 is equal to x over 3 minus 3. Okay, you can reduce this to more simpler forms. This is y minus 6 or y is equal to x over 3 plus minus 3 plus 6 is plus 3. Okay, you can leave the answer here only. Okay. So this is the equation of tangent at point t is equal to 3, right? Fourth part says that we have to eliminate the parameter, which is t in this case, and hence sketch the curve and the tangent at the point where t is equal to 3, right? So basically we have to eliminate the parameter t means we have to write the Cartesian equation of the curve, right? If the coordinates of any curve are given in terms of some parameter, like in this case that x is equal to t square and y is equal to 2t. So basically the parametric equation of the curve is given. Okay, there won't be any other parametric equation of a curve which involves just a parameter theta, right? If x and y coordinates are given to you, that means inherent in this is that the equation of curve is given in terms of parameter, right? So x equal to t square and y equal to 2t, this is the parametric equation which is given, right? So do not get confused that these are just the coordinates. So how we can find out the parametric equation? This is your parametric equation, right? And using these two equations, we can eliminate the parameter t to find out the Cartesian counterpart of this parametric equation, or just the Cartesian equation, which involves just x and y. So what we have to do, if the question says that we have to eliminate the parameter, that means it is asking about the Cartesian equation, right? Sometimes question can be asked in opposite form, that find out the Cartesian equation of the given parameter equations, right? So there only there also you have to eliminate the parameter t. Okay, so let us eliminate these parameters. If x is equal to t square and y is equal to 2t, so how can I eliminate t? It is very simple, that find out the value of t from any one of the two equations and put it in the other one. So let us say that I am putting t as y by 2 in first x is equal to value of t is y by 2 whole square. Okay, so this is y square over 4, right? So Cartesian equation is y square is equal to 4x. Okay, y square is equal to 4x, and then we have to sketch the curve. As you can see that this is a parabola, but not the upward or downward parabola. We have two other kinds of parabola, basic you can say types of parabola. One is upwards and downwards, whose vertex is at the origin. Similarly, if I tilt the upward parabola like this 90-degree, I get two horizontal parabolas also, whose vertex is at the origin, right? And their equation is just that you can replace x and y coordinates. Okay, so this is a parabola. Let us quickly sketch the curves. Suppose this is your y coordinate, no, y axis, this is your x axis, this is y, this is x. Okay, and this is y square is equal to twice of x. So this type of parabola is like this. Okay, and then we have to sketch the tangent also, right? Equation of tangent was x by 3 plus 3. Okay, so equation of tangent is y is equal to x by 3 plus 3. I think this is the equation. Let us quickly check again. This is y minus 6. Yes. Okay. Now, at the point t equal to 3, we have to sketch the or draw the tangent. So at t equal to 3, what were the x and y coordinates? Let us quickly find that also. So at t is equal to 3, y coordinate is 2t, which is 6, and x coordinate is 9. Okay, so let us take my x coordinate is 9 and y is 3 here, and here I have to sketch the equation of or straight line y equal to x by 3 plus 3. As you can see here, the y intercept here is 3. Okay, so this is your tangent. Okay, sketching means it is not about just to sketch the straight line or just to sketch the tangent. It is also about mentioning the point of intersection. So this y intercept is basically your 0,3 point. This also you have to mention. Okay, and this coordinate means x and y coordinate also you need to mention. Either you write this x coordinate here, which is 9, 0,9 you can mention here, or you can just mention this point at point P. This is 9, sorry, this is not 0,9, this is basically 9,0. Okay, so this is 9,6, y coordinate is 6, x coordinate is 9. So this is how you can sketch the curve and equation of tangent. Okay, let us do one more question. The parametric equation of a curve are x equal to a cos cube t and y equal to a sin cube t. Okay, just remember the trigonometric differentiation. Okay, here it will come into play. So where a is a positive constant and the parameter t, it is lying between 0 to pi by 2. Then we have to find out first part, express dy by dx in terms of t. First part I can do here only, that dy by dt, because again we have to differentiate with respect to t only. So dy by dt is 3a sine square t, as sine cube t derivative is, you first differentiate this, apply the chain rule basically. So sine cube t will be differentiated first with respect to t and with respect to sine t, and then sine t will be differentiated with respect to t. Okay, so within this parameter also chain rule is applied. Okay, you can think of sine t as another parameter p, right? So I'm doing dy by dp and then dp by dt. Okay, so just remember the chain rule. So I'm doing this directly, that first differentiate this with respect to sine t, which is 3a sine square t, and derivative of sine t is cos t, right? And dx over dt will be 3a cos square t, and derivative of cos t is minus sine t. I'm applying this minus sign in front. And dy by dx is, you just divide these two equations. Okay, in LHS you will get dy over dx is equal to 3a will get cancelled with 3a, this single cos t will get with cancelled with this single, and this sin t will get cancelled with this sin t. You get minus sin t upon cos t, which is minus tan t. Okay, this is your first part. Let us do the second one. Show that the equation again of the tangent to the curve at the point with parameter t is this one. So equation of tangent obviously is x minus x1. What is your x coordinate? It is not x minus x1, y minus y1 t. So y minus y1 means a sine cube t is equal to minus tan t. I am writing this tan because the final equation is in terms of sine and cos only. So I am just writing tan t in terms of sine and cos. So this is cos t, x minus x1 is a cos cube t. Okay, so let us solve this, simplify. Let us take the LCM. This cos t will get transferred to RHS, not on RHS, LHS. So you have y cos t minus a sine cube t into cos t. This is equal to minus x sine t plus a sine t cos cube t plus a sine t, yes, cos cube t. Okay, that means y cos t plus x sine t, transferring this term to LHS and transferring this term to RHS. So plus x sine t is equal to a times sine t cos cube t plus a times sine cube t cos t. Okay, cos t. Again we can simplify this further. This is y cos t plus x sine t is equal to, I can take out a sine t cos t as a common factor, sine t cos t as a common factor. You remain with cos square t plus sine square t. Okay, and as you know that sine square t plus cos square t is our famous identity, that its value is just 1. Okay, so your final equation is y cos t plus x sine t is equal to a cos t sine t. Equation of the tangent at general point t. Okay, hence proved. This one. Third part says that hence show that if this tangent meets the x-axis at a at x, the y-axis at y, then length of xy is always equal to a. Okay, so let us take a fresh page. This is your y, this is your x coordinate, x-axis, and equation of tangent is your y cos t plus x sin t is equal to a cos t sin t. So my x-intercept, where it will intersect the x-axis, there y will be 0. So let us put y equal to 0, x you will get as just a cos t. Okay, in this equation put y equal to 0, this will get eliminated. You will get x sin t is equal to a cos t sin t. Sin t you can cancel each other. Then x coordinate you will get just as a cos t. Okay, so x coordinate is your a cos t. This coordinate is a cos t comma 0. Similarly, if you put the x coordinate as 0 to find out the y-intercept, you will get your y-intercept as a sin t. Okay, this is 0 comma a sin t. Okay, and this line, length of this line, you have to show that this is always equal to a. Using Pythagoras theorem also you can find out, or you can apply the distance formula. Any method you can apply, you can see that if this coordinate is y, this coordinate is x, your xy length is equal to y2 minus y1 means a sin t whole square plus x2 minus x1 is minus a cos t whole square, whose square is just this one, and under root of this, right? A square sin square t plus cos square t will be equal to 1. You will get length is just a units. Okay, so if you see the question in one look, it will look to you a very long question, a very complex question, that how we can find out the x and y intercepts, and then there are some sine theta cos theta, not only just sine theta cos theta, there are sine cube theta and cos cube theta, how we can manage. And then there is some parametric differentiation also, there is chain rule also, right? But if you follow the basic rules of differentiation, right, how chain rule applies, and this how chain rule will apply to the trigonometric functions, and how these chain rule and trigonometric functions, they are in the last are used in parametric differentiation, right? You can also find out the stationary values of also. You may add the fourth point as hence find out the stationary point, right? And then determine the nature of the stationary point and so on. Okay, so from my side, this differentiation chapter for your A level paper number 32 is over. You can follow me on Instagram also. You can follow me on Telegram channel and various worksheets. I am starting the Telegram channel and they have been uploaded. They will be soon be uploaded on the Telegram channel, where you can find out various worksheets and assignment for various topics. Okay, next time we will see how we can integrate the functions, means the next topic, next chapter in this is your integration. Till then, take care. Bye bye. See you. God bless you.